Hello, everybody.
Hello, everybody, and Pablo,
We're going to get better at
completing each other's sentences.
yeah. My name is Pablo. I am working with all of you on these online courses, and here joining me is Daniel, who is
And
also doing that.
yeah, Pablo
Cool.
is a promoted person. I'm a grad student, and I think we'll both introduce ourselves in the forum.
Oh, you're introducing in the forum. Fantastic. If you have not done this already, please introduce yourself in the forum. That should be, we need to put that link in this, but we will do that. Anyways, today we are going to do a podcast-like versioning where we're going to go over the first very solid iteration of an online guide for Python starters. Daniel here has written 100% of this guide. I have seen it a bit and it looks fantastic. And what we're going to do, we're going to provide you with this company guide video and audio to go over it. If this is the first time that you're coding in Python, you're not alone, you have friends to go over it. And if this is not the first time you're coding in Python, you also have friends that are joining you over. So we're going to go over it and then you can play with it and learn stuff. Anything in general that you want to comment to our friends, or we start?
I think you got it. Let's go for it.
Perfect, very good. So let me share my screen. And Sumi's recording, right? Yes, because I could hit, well, yes, I could hit stop recording. So that means that Zoom is recording. Good, that is good to know. Okay, friends, you are seeing the GitHub repository in the Ascension GitHub, or Ascension Organization GitHub, where we have these online guides for all of these concepts that are important for you to learn. And in here, we're going to start with Introduction to Python. There's going to be many other resources later, and we're going to put these in a Jupyter Notebook format. But for now, let's focus on this one because you want to learn how to code in Python. Now you have a couple of things that you could do. You could just click on this, and then you will open what is called a Jupyter Notebook. How I define a Jupyter Notebook, Daniel?
It's sort of like an interactive way to run Python. You can run little bits of code at a time. You can put nice comments. As you can see, it's written as if it's like a guide on a website somewhere, but you can run the little code snippets.
I like it very much. When I started learning how to use Python, I used to have Python scripts. Those are the files that are called like something.py. And for me, I was only able to just run the whole thing. But with this, you kind of can execute different cells. So you could look at this in this way, but we're going to go back and we're going to open an online cloud computing enabled something that basically allows me to run this code. And that way we can play with it. So you're going to, before probably you have to click on like watch, fork, star. I think fork is important because that will create a copy of this repository for you. I own this repository, so I don't think I need to do that, but for you it might be important. Once you have done that, you can, and if you click on watch and star, I think that is like clicking like and subscribe, so you can be subscribed to more content that we're going to be releasing. Anyways, let's look at the code one. If you click in here, local, you will be able to download this thing if you want to play it on your computer, but if you want to play online without having to install anything, you're going to click in code spaces, and in here you're going to add this plus that you're going to open this in your own code space, and then GitHub is setting everything, and you have this I guess virtual machine where we can run all of these codes. So now this is opening the things, it's setting it up, and now here you see that here's my mouse. I have all the code that was available in the GitHub repository, and I can click on each one of them. We're going to click in the introduction to Python. And now I can run these cells by themselves. It's going to ask you if you want to install Python. Of course, you're going to say, yes, I like to have Python in my virtual machine. And then at some point, whenever we start running things, it's going to ask us where we want to run it, and we're going to select something in there. So I am kind of blind, so can I? Yes, that looks better for me, and I'm going to close this terminal. So let me just try it so that it asks me, and then we can do it. We're going to install Python on Jupyter. Now this thing is installing everything, and we should be good to go. So here is the introduction to Python Daniel has written. You can read, but we're going to, okay, Python environments. Python 3.10. Okay, now this thing has access to Python and is able to run things. So Daniel, what is this first cell that we have in here? What are cells? How do we run cells? So many questions. Go.
Yeah, so when you're running this on your own, there's a couple of different ways to run it. At the very top of the screen, above the introduction to Python thing, you see a button that says run all. You probably don't want to use that because the point of the Jupyter notebook is you run things one at a time. On the left of the cell, which is the snippet of code, you see a triangle, and you can press that to run. It also tells you have a shortcut there. So
I actually usually run it by clicking and hitting Shift Enter. And
Yep.
it runs it, but both work.
However you want to do it. So we're going to start sort of stereotypically. If you ever look up any starter Python guide, it will tell you to start by printing hello world. When you're actually working with code that you haven't written or code that you haven't touched in a while or writing your own code, the very most basic thing you want to do is figure out what's happening at a certain point in the code. The easiest way to do that is to just print out whatever variable thing you're looking at. So Python is very nice. You just type a print statement and then the thing you want to print. So the first example there is hello world. And then you can print a...
Could I change that? What if I want to say hello world, this is Pablo? Will this work?
You're only able to do that if your name is Pablo. Otherwise, this doesn't work.
So for all the Pablos out there, you can actually do this and it works.
So yeah, so that's most of your data is not going to be stored inside of print statements. I mentioned earlier that you want to access what different variables are. Variables are how Python associates a word that you can read with the data inside the computer. So Pablo, if you click to the next cell, the simplest variable I can think of is just a number, and my favorite number is pi. So pi is 3.14 whatever.
Is that the password of your phone?
Not anymore, it's not.
It's still mine.
So
everybody online now can hack into my phone if they have access to it.
If they have access to your phone, you're in trouble anyway. But so you see, we store the variable pi and we call it the word pi. We assign it using the equal sign. And now if you run this cell, you see that we print the variable pi, pi, and the number comes out of it. So we can compute things with this. If I wanted to compute the area of a circle, I can assign a variable to my radius. I'm going to say r is equal to 2. And then I use the formula for the area of a circle, pi r squared. And then you see I print it out. If you go ahead and run this code
So what does everybody at home think that this is going to print?
Whatever 4 times pi is.
No, I mean the number. Like whenever I hit run, what is going to happen? We could play a Dora the Explorer type thing.
Okay.
You got it. Yes, indeed it prints that the area of the circle is 12.5 something.
Okay. When does swiper come in? So the first thing you notice from above is that we actually can use arithmetic operations. And it's something you would hope for in scientific computing. So you see multiplication.
This power is a weird way of writing power.
Yeah, it's a little bit weird. Sometimes other languages will use sort of a caret like thing. Python.
Like this, for example. This is how I will write it.
And Python doesn't like that. And
I guess it's going to complain. Like, yeah. Oh, I don't know what this is.
Yeah, so don't do that. Powers are those 2 stars. Multiplication is 1 star. The other arithmetic operations are basically what you'd expect. You have addition, subtraction, and division. So if you run that, it does exactly what you'd expect. There are, a lot more operations you can imagine. Those will show up sometime later. But so let's what we want to do now is dive a little deeper into these objects we're actually manipulating. So pi is a number. Hello world is not a number. How does Python keep track of what is what? Well, okay, you can assign a variable to the statement Python is fun, just like you could have done it for hello world above if you wanted to. And so if you run this statement, you see that Python says, oh, well, my variable is this statement Python is fun.
Now I'm curious. I'm going to write a new cell, and for those at home, if you want to replicate this, you click in here plus code, and it will create a cell in where you can make code. If you want to create a cell in where you can make text, like Daniel is showing, you click in here and you make markdown. So this is text, but this is not text. And if I try to run this Python, it's going to ask me, what the heck are you doing?
Yeah.
The reason why I wanted to do this is because, and now I'm curious, what happens if I were to grab my variable and I try to do a mathematical operation to it and add my radius? What will happen in here, Daniel?
Yeah. Well, let's let the viewers take a second to think about it.
That's
Okay.
right. It doesn't work.
Yeah. So the reason this stuff doesn't work is because these are different data types. You see that the variable my variable is what's called a string. That stands for, what that means is literally just text. So you could, in fact, have a string that looks like a number. If you go to the next cell, you actually see the difference here.
I want to get rid of this nonsense because it's going to annoy us. How do I
On the
get rid of
right-hand
this?
side, you see a
Oh.
trash button.
Oh, so you click in here and it's going to destroy the entire notebook?
Yeah, but that's what GitHub is for.
Okay. Oh, not the entire notebook, just a cell. Okay.
Yeah, so in this cell, if you go ahead and if you look at the difference between the two print statements, you see that one has a single quote around the text, the other does not. So 2 and 3 are integers. If you add 2 integers, you get another integer. But if you wrap the whole thing in quotes, Python just treats that as the text that you've written. So if you run this cell, Pablo, you see that the top line is saying, oh, well, I just printed the string you gave me. The bottom line is actually doing the operation. So this is because the different data types are different data types. One is a string, one is an integer. And if you're ever unsure, Python lets you check this using the type function.
I didn't know this existed.
So this is useful in case things are going wrong and you want to figure out what's doing what and where. And so I've already told you the number 3 as stored in Python right now is an integer. And you see type of 3 is of class integer.
Integers are classes?
But that's how Python does things under the hood.
Oh my goodness. That's
so
incredible. Okay.
Yeah, and then you see that when you put 3 inside of quotes, it becomes a string. Python treats it as a string.
Yes, perfect.
And here's the example of what Pablo was showing before. What do you do? Oops, you can't add an integer and a string.
Yeah, that makes sense.
So this is, whenever you see something called a type error, that's because whatever things you're using are not compatible with each other.
I didn't know that either. Oh my goodness, I'm learning so much.
Yeah.
Oh, perfect.
So good.
Okay, what happens if we try to add pi to 3? That should work.
Yeah. So in some languages, it doesn't. Historically, it used to complain because pi is a floating point number and 3 is an integer. Python doesn't care because you don't care and you're using Python, right? It's a number. A number is a number. Let me add 2 numbers together. And Python behaves the way you would expect. As a warning, when you're using other programming languages, this may or may not be true.
Yep.
But for now, you don't have to care about that.
Very good.
And now if you actually take a look back at that previous thing, say, look at the top print statement in the previous cell. You already know, because it's surrounded in quotes, that the statement type of pi is a string. But then when I actually call the function type of pi, you get a float. Well, the print statement doesn't care. The print statement is sort of the ultimate debugging tool. It lets you print anything you want so long as you separate things of different data types with a comma. So, for instance, in the next cell, you see a more detailed hello world statement.
Let's run it.
So you see it actually fills in the value for pi, and it actually does the arithmetic operation, and then prints everything else that's in quotes as a string.
I actually didn't know that you could do this either.
Yeah.
But this is wrong. 2 plus 2 is not 4 factorial. I'm being annoying.
You hush.
I'm being annoying. Funny enough, actually, this is the time where we entertain our viewers. When I was back in Venezuela, I was reading a book that was the 3rd book on quantum mechanics by Feynman. And there was a moment in where Feynman is talking about bosons and he's making some calculations with exchange of particles and blah, blah, blah. And the text says, it's a translation in Spanish, that after these operations, you should have n particles or n states. And I remember thinking, like, that's weird. For me, it's way bigger than that. And it took me a couple of days to realize that they were saying, and you have n particles, because in Spanish, you close with the factorial. And Feynman was actually saying that it's n factorial, but whoever was translating this thought that Feynman was very excited. that it was
Yep.
n particles.
I have similar stories, not translation issues, but everybody the first time they see a factorial says, "Why is this guy so excited about this thing?" So
very good.
yeah.
Okay, so
So
what are we doing in this part?
now we're going to move to actually doing something with Python.
Mhm.
We've sort of explored what different variables are and how to print them and store them. But suppose we want to do something pretty basic. Let's just compute the area of a bunch of different circles.
Mhm.
Well, as you've already seen, you can just type in a bunch of print statements and then do arithmetic operations on them, and you see that it works fine. If you want to do 2 or 3 circles, you can do this and it will work just fine. Suppose you have a whole bunch of them. You don't want to copy paste 10 print statements.
Which I have seen people do that by hand, and it breaks my heart.
It's kind of funny. People sometimes do that stuff in Excel as well. I hear stories occasionally about people using Excel as a data table and then doing arithmetic operations one by one on their calculator. Yeah. So Python, just like Excel, knows that that's not an efficient way to do things and has things built in that let you do them in a non-repetitive way.
Very good.
So the first thing I want to talk about is the list. If you create a list, I mean, if you think about like a bulleted to-do list, that's essentially what a Python list is. It's just a collection of elements inside of square brackets. And you can see that Python calls it a list. If you run this cell and check the type of it, you say, hey, okay, it's a list. So whenever you see something that says it's a list, it behaves like a list. I'm saying a list of very lot.
List.
Yeah. So if you think about how you would actually compute the area of a circle for a whole bunch of circles, you say, in your head, I'm going to take the first element and I'm going to compute the area. Then I'm going to take the second element, compute the area. Third element, compute the area, and so on. So this is how Python handles it, essentially. You have just described mentally a for loop. For item in list of items, do thing to item. In this case, we say for radius in my list, compute the area of the circle with that radius. And if you run that loop, you see that that's exactly what happens.
And it's the same that you got from here.
It's exactly the same. In this case, because you only have 3 radii, the amount of code is actually more when you're not copying the print statement, but you can imagine large numbers of things for
If I have
loops.
50 circles, I will be very annoyed to have to write this way.
Yep, and whoever is grading your code will be a little bit
extremely annoyed. What is this?
Python lets you do things a lot of different ways, which is actually weirdly contrary to some of their stated intentions. But in any event, what this is called list comprehension. It's a way of writing the above statement in just one line.
Do you comprehend why it's called list comprehension?
Nope, and I think you've asked me this and I forgot to look it up.
No problem.
But
we still don't comprehend it. Maybe
yeah.
There's 25 people right now writing comments on this YouTube channel,
That was the
correcting
one
us.
question I had. Why didn't you answer it?
Uh-huh.
Yeah, so what this actually does is it looks like a list because it's in square brackets, and you see its operation, pi times radius squared, for radius in my list. So it's a little bit of a twisted syntax, but you'll see this occasionally because it's nice to put things in one line instead of a bunch of them.
I'm realizing that these words are in different colors. And I guess that this is code space ability and many code editors to detect patterns and tell you like, yes, I'm understanding even before running this, that this is going to be a list comprehension.
What it doesn't detect that. What it detects is there are certain terms in Python that are reserved. So I don't know if you can name a variable for.
Most likely not. If
That
I
would
want
be
to say like radio, no, exactly.
If
If
you
I
said
want to say 4 is
equals-
equal to 4,
it's going to complain.
it's going to complain. But if I were to say 4 with 2 R's, that I can do, right?
Yes.
Yes, because 4
Yeah.
is not
So there are words that Python doesn't let you assign to variables for good reason.
Yes.
So
that makes sense.
But okay, so
Okay, let's run this thing.
Run that, and you see it prints this whole thing, and now it's actually in a list. So you have done the operations and gotten a list back. So that's something you often want. Lists you're not always creating lists. Sometimes you're handed them and you don't know what's in them and you don't know how long they are. Python lets you just figure it out. You print length of my list and
It's
it
3.
says I have 3 options.
Oh,
There's a
to avoid confusing our viewers, I'm going to put 2 dots in here.
okay.
And then, I don't know.
Yeah.
Aha,
So
go ahead. Sorry.
yeah, so you can see that whenever you have a list and you don't know how long it is, Python lets you figure that out. Other older programming languages were not happy about that. They would just let you iterate until you go outside of the list, just because it doesn't have any idea how big the list actually is. You can also say, I want to just make a range of values, so from 0, 1, and 2. This brings me to a very subtle point that people often find confusing when studying Python. Python starts lists counting at 0. So the first element in my list is 0. The next element is 1, and you access them using the square brackets. So you see, I'm going to loop over what this is doing is saying I goes from 0, then 1, then 2. This is just looping over the number of elements in your list.
It stops at 3, not including 3. So
Right.
before 3.
It does not include the last element. Again, things differ between different programming languages, so be very careful. And you can see I start at 0 and get the first element of my list. And in fact,
the number 2.
Yes. And then I can compute the area. Similarly, I get the next element of my list is I equals 1, and so on and so forth.
Fantastic.
So that's good. But the things you want to do are more complicated than can normally be put in a loop. In this example here, I say, suppose I want to compute the ratio of the area of the circle to its radius. I can do that. There's nothing preventing me from doing it. In the list comprehension example, it works. What if I want to do things more complicated? Well, this is where we introduce one of the fundamental concepts of not just Python, but programming languages in general, called functions. What these do is they take in an argument, do some operations, and return some other argument. You create one in Python using the def statement for define, and you say, I'm going to call my function area. In parentheses, you put in the argument or it takes, and you use the return statement to say, exit the function and give me back the value of my operation. So I define the area given a radius, and it returns pi times the radius squared. And then you can go through your loop using go through your list using a for loop and compute the area of each of them.
Without having to explicitly put the formula here, but rather now this is a function that you can call. And people call this calling, I don't know why.
Yeah.
But you're calling it.
Yep.
Perfect. This works.
Functions are oftentimes you want to use multiple arguments. They are defined just using a comma separation. So you feed in radius and pi, just in case you feel like you really want to change the value of pi later.
Maybe that you're in non-planar geometry and the value of pi is bigger or smaller.
Yeah.
That can happen.
But you can suppose, yeah, I'm probably almost always in flat geometry, so pi should have a default value.
But if I want to change it, I could modify it.
Exactly.
Yep.
So you define, for variables that are meant to have a default value, you assign the default value in the definition of the function. And then when you're calling the function, you don't have to supply that argument. So if you just look at this loop, you see area of radius doesn't involve pi at all, and you see that it computes things just fine. There are a couple of different ways to supply a value. I could supply the value using a named value, or I can just put it in as the next argument in the function call.
I have to say, the first time that I was reading Python code that was relatively advanced, these type of things confused me so much. I was like, why? What does it mean that pi is equal pi? Of course, pi is equal pi, because I was thinking it from a mathematical point of view that, well, with pi is trivial, but they will have like L values equals L values. And he's like, what do you mean by this? This confused me so much. Daniel, can you explain this?
Yeah, so what you see, let's just look at the equal sign. We already know what radius is doing, so we'll leave it at that. The left side is the variable that controls it's the name of the variable inside of the function.
Mhm.
So if you actually look up at the function definition, you see I've called my variable there pi.
Mhm.
The variable on the right is whatever I've stored outside of the function. And so, oh, Pablo's doing something.
Yes, I'm going to explain this with arrows because that's how I will understand this. But yes, continue.
So, I think you want the next one. So, yeah, arrows are probably going to be helpful here. So, let's see. Within a function, this is maybe the first point to make. Within a function, variable names do not impact things outside of the function. So the variable name radius inside of the area function doesn't exist outside of the function. If you try and evaluate it, it will throw an error. It doesn't exist. Similarly, the variable inside of the function that I'm calling pi only exists inside of the function.
Even if there is another pi defined outside.
Right. So I, in the second function call, have defined a variable outside of the function that I am calling pi. And then I'm feeding it into the internal context of the function itself.
So this is the outside variable, and this is the inside. It's really hard to write like this. Inside.
You're doing a great job, and that's exactly right.
So the way, let me comment on how I see it right now. Basically, whenever you have this statement in here, this is telling you, okay, I'm calling this pi because I'm a human, and that is easier for me. But this is a memory direction, and I'm just going to replace this by, let me release this. I'm going to replace this by a red square. And this function is just saying, okay, I have a red square, which default value is 3.14, blah, blah, blah. Oh, here is my red square. So this is where the value of that red square should be. So whenever you come to this part of the code, this left side is that same red square. It's just that it happens to be, because we're humans and we're lazy, that we put the exact same name. And what this statement, I'm running out of color, of space, is saying is, remember that red square? Replace it by the numerical value of this other thing that is defined outside. And that is how I view these things. Do you agree?
Exactly. Yep, that's exactly right.
Okay, we go back to our code. So now I'm curious, if I were to run this, we get this, I'm going to create a new code, and I'm going to ask, do you know what is radius? Well, it knows that it's 4, but this is unfortunate. It knows that it's 4 because we defined it like here in one of the things before, but not because this radius is
Yeah. So you could define a function and have the internal variables just be A, B, C, D, whatever. The reason you don't do that is because when you read the function, you want to know what they stand for. It's sort of bad code design to name things that are unrelated to what they're doing.
Yep. And usually people can comment on their codes. These ones are so tiny, they're 2 lines, so maybe it's not worth it commented. But if you wanted to,
we'll have to
right in here, you have that later.
We'll have an example of it
perfect,
later.
fantastic. Yep. Okay, very good. So where were we? I think I derailed us.
Yeah. So we're moving now to Booleans.
Yes. What is Boolean?
A Boolean is a true or a false statement. Some things are true, some things are false.
You know that there is I keep derailing the conversation. There is a branch of mathematics that believe that things can be something else beyond true and false.
Yeah. Python disagrees with that.
Python disagrees with that branch of mathematics. So Python is not doesn't agree with constructivism.
Yeah, well, you can take it up with Python and see what it tells you. Okay. So within Python, you have true and false statements. True statement is one that they behave like true and false statements. So if you say, if statement is true, then it will do one thing. If statement is false, you can do another. The motivating example here is, suppose I go back to my function where I'm computing the area of a circle. Python doesn't distinguish between a positive floating point and a negative floating point. It doesn't care. But you, the person computing the area of a circle, know that a circle with a negative radius doesn't make sense. So what we're building up to is, how do we check for things that do or do not make sense? And what do we do
You have the radius
Yeah.
here. Okay, so all of these, you can read it if you want, but it's just different ways of selecting when things are true or false. Now
Before
you're
we go,
implementing it to the
yeah, just going back up real quick to the previous statement,
Yep.
the key point I want to make here, so I mean, quite aside from Boolean operations on numbers, you have the if statement. The if statement is how you check whether something makes sense or not. Literally, if this statement is true, do one thing. Otherwise, do something else. And you can nest them, and you see some examples in that cell right there.
So my variable is 3. This is checking. If my variable is 1, print this. That is not the case. If my variable is 2, print this. That is not the case. If my variable is 3, print this. That is the case, and that's why that's what got printed.
Exactly.
Perfect. So what do we do with the
We're
area?
going to put this all now together inside of our area function, including the comments that Pablo mentioned just a couple of seconds ago. So
these are comments.
yeah, so there's two different ways to comment things in Python. One is using the triple quotes, and this is, you'll commonly see this to define what a function does, what arguments it takes in, and what it returns to you. Comments starting with the pound sign are typically used in line. So here I'm saying, well, the reason we have this if statement here is because we're checking to make sure that our circle has positive radius. Now you see, I say if my radius is negative or 0, that's what the less than or equals to sign says. I don't want you to compute anything. I don't want you to do anything. I want you to throw an error. I want you to stop the code execution in its tracks. Something has gone wrong. So you can actually do that using this raise statement.
It's like a flag. You're literally raising a flag that there's something wrong. Stop.
Exactly. You don't always want to do this. If you're making a website, you don't want the website to crash whenever somebody does something wrong. But if you are running scientific code, you would rather it stop than it keep going doing nonsense.
And then give you an answer that you might believe.
Exactly. So you see that I don't actually need the else statement. It'll check the if statement and then it'll do the rest of it. And if you run this, you see I have two different radii. I have a radius of 2, and that computes fine. And then I have a radius of -4. And you see it says, oh, that's a value error. That doesn't make sense. There's a whole lot of different types of errors. You can feel free to look those up in your own time. Sometimes it helps know what the context is. If it's a type error, that's because I tried to add a string and a float. If it's a value error, it's, I don't know, some custom thing I've put here. If it's a runtime error, it's because it's been running for 300 million years and Python doesn't want to do that anymore.
What if you, for example, do 1/0? Will that be a value error? Zero division error. It has its own special error. That's nice.
And so you see, not only can you raise an error, you can add a message to it. So you see radius, I see a value error, radius must be positive.
Which is nice. So do you know what exactly happened?
And it tells you where the error is. With more
yeah, that's nice.
It's sometimes less helpful than you might hope because it traces back all the different things that have gone wrong. In this case, we only called one function and one thing went wrong, and so we can see exactly where it is.
Perfect.
Later on, when you're using other people's code in Python, this becomes less helpful because you'll have an error in your function that calls another function that calls a third and a fourth, and then down here, it actually raises the error. But it's still a useful debugging tip, and certainly better than not having anything at all.
So now we're going to teach them classes.
Yeah, the very last thing I want to talk about in this lesson is classes. These are confusing, not the least of which because if you're trying to find like an online guide for Python and you search Python classes, it comes up with the thing called a class in Python rather than the class teaching you Python.
And I imagine there are classes teaching classes.
Yeah, so that was a big sticking point for me when I was first learning Python. Python is what's called object-oriented. Really, what that is it means you define things that are called classes, and these classes have an internal context window that's separate from the main bunch of the code. Sort of like what we were talking about with functions earlier. Radius and pi only exist within the function, but they only exist while the function is being called and then they're discarded. Classes keep them around. And so that's a nice thing to have. You define a class a little bit similar to how you define a function. You start by saying it's a class, and then you give it a name. Then it has some different class methods. which are basically functions internal to the class itself. The most common one you see is this init method. That says I'm going to take whatever variables I have, in this case my variable, and I'm going to store it in my context window. So I'm going to keep track of the variable, my variable, and I'm going to access it by calling self.myVariable. Self, when you're looking at class methods, the first argument, you'll typically call it self, and it's a special argument. What that means is this is a function defined within this class.
Okay. Why the word self? Because it says
It's mostly convention. Technically, Python will let you use anything, but if you see the word self, you know that it means this is a class method, and I don't need to worry about that.
Okay, so let's define the class. I'm not initializing the
Yeah,
class.
so it's a little bit weird. The main way in which, or rather the first way in which classes are different from functions is that you now have to make what's called an instance of a class. What that means is I assign one copy of the class to my variable. So you see, I access it this sort of the same way I define that I call a function. And now if you actually run it, you can see what type it is, and you see that it's defined as the class, my class.
Okay.
Incidentally, this is how you know that this ties in nicely to like a list. You see that the type of a list is of class list. So that's the sort of thing. You see that everything is actually object oriented under the hood. You don't need to worry too much about that in general, but it's a neat little tidbit. But how do you actually use classes, right? So we've made a class and I've told you it has an internal set of variables. The way you access those variables is by using the dot. You say, I take my variable name, and then I do dot, and then whatever thing inside of the class that I want to access. So
this should print an input variable, if I'm reading this correctly.
Exactly.
Very good.
So that's stored in there. There are other weirder ways to get things. This get attribute,
No idea.
it's doing the same thing. This is useful for when you have a whole list of attributes that you want to get, because you feed in a variable. You see the string my variable on the right. I can replace that with a Python variable. And if I have 6 different strings I want, I can literally make a loop through those strings and use the get attribute statement on each of them.
Okay.
It's a bit of a niche thing, but it's something you can do. So now we're going to make another copy of the class, and we're going to call it
but is it still called my variable?
Oh, sorry, I'm getting ahead of myself here. Yeah, so we're going to make a new variable, and we're going to call it the same thing as what we called the thing inside of the class. So if you scroll back up to the class definition real quick, keep going to where we actually instantiate it. You see that I've said I have my internal thing, and I'm calling it my variable inside of the thing. Now, in this cell we're about to evaluate, what you'll see is that you still have my variable defined everywhere, and you also have the same thing, my variable, defined inside of the class. And they're two different things, and you have them both at the same time.
Okay, exactly. So if I print my class dot my variable, that is whatever that variable was inside the class, and that should be a different thing than the one that I have defined globally.
Exactly.
And okay, that makes sense.
So
that makes sense for you? You got it. Fantastic.
If it makes perfect sense, don't say anything right now.
We're doing a fantastic job.
So let's go back now to our example from earlier.
Yeah, because this seems so simple that it's useless.
Exactly.
So
you're not doing anything here.
And we keep with circles. We have so many circles.
Yeah. So we're going to define the circle class. Honestly, the main reason I use classes in Python is just to group associated functions. If I have a whole bunch of functions that need the same variable, say the same harmonic oscillator width or the same mass, and they're doing things using that same mass, I'll just group them together into a class for readability. So that's what we're going to do here. So you see our circle class has an init method. I'm going to tell it the value of pi in my init method. And then it has two functions that go along with it, the area and the radius. For both of these things, technically, when they're in a class, they're called a method, not a function. People will understand what you mean when you talk about a function inside of a class. You see that their first argument is still the self. That is still saying this function is defined for an object of this class. Outside of this scope, I don't have a function called circumference. If I try and do circumference of radius, it's going to throw an error. Now, I again instantiate the class by saying circle of pi.
And the reason why in here you have pi is because this is supposed to contain the number pi, but I see two arguments.
Yeah, so that self argument is, again is saying that the init method is defined for the class itself. So it's the class initialization method rather than some general initialization method.
Okay, so every time I will always have to put this self
Yes.
here. So if my class didn't, in principle, take any arguments,
If
I
your class
just-
doesn't take any arguments, you don't actually need to define an init method.
Okay,
Yeah.
okay, okay.
This is all kind of complicated. If you
I
have
understand.
questions,
Should
you or the audience shoot me an email.
Yes, we also have the forum
Yeah.
that you should all have by now, but yes, very good.
Yeah, so we're going to make an instance of our class, and then we're going to compute the radius of a bunch of different circles,
Okay,
just like we did before.
same numbers as before. That's
Yeah,
great.
and you see now the function we're calling inside of the print statement on the right is my circle, which is the class instance. We access the function using the dot operator and then the name of the function.
Perfect.
And you again see that when we're calling it, you don't need to provide the self argument.
Perfect.
And now we can make, the point of this exercise is now we can make different instances of classes. So we have one class where we're in normal geometry where pi is 3.14. Then we have a different weirder geometry where we're calling pi 2.
Pi happens to be 2.
Yeah. And so you see we've made a list of the classes, and then we can compute the radius in no, sorry, this is the attribute. This is the area of the thing. So we can compute the area of each of the circle of radius 2 in each of these two different geometries. So we first loop over the list of classes.
That is this part.
Yep. And then you see the get attribute thing comes back.
Which is saying, I know that for these classes, there has to be a function somewhere that computes an area. Get that function and evaluate it in a radius equals 2.
Exactly.
This radius is different than this number. This is pi.
Yeah, that actually should be the variable my radius. I defined it above and didn't use it.
Oh, my radius.
No, just 2 lines up.
Okay, perfect. So we copy this in here. There we go.
Yeah. That
Okay.
makes more sense.
And nothing changed.
Yeah.
Perfect.
So this is why you might want to use the get attribute. The last thing I think I want to talk about with classes is you can change the internal state of the class. So here we start by making a class, making a circle with pi equals 3.14. So that's the first line. And then we say, what is the value of pi within this class? And we print that out. Then we say, no, but I insist I'm in a weird geometry. CLS.pi equals 2. That's saying the variable within that context is now 2. And I print it and you see it's changed.
Perfect.
You can do a lot of really wild stuff with this. Not only can you change the variables within a class, you can actually change the class functions themselves.
Of course, that makes sense.
So that's a very useful thing in certain contexts. This does get into some of the theory behind Python. You'll hear people, when they talk about object-oriented programming languages, talking about class inheritance and polymorphism and private and public methods. It's a rabbit hole. It just keeps going and going.
Really interesting.
There are good reasons to use these things. They are complicated, and in most of your scientific computing time, you probably won't use them. So we're not going to talk about that here.
Very good.
And I've left a few resources below, just some very basic ones. Python has guides. There's some style guides. There's some ways of managing your different packages. Pablo, if you have any good references you would put here,
that's a good idea. Yeah,
feel free to add them. The next Jupyter notebook discusses how to use different packages that people have written, different bits of code that people have written. if you want to make a plot in Python, you could spend probably your PhD making like a good plotting routine, or you could use one line of matplotlib and be done with it. And that's true for an awful lot of the things that you want to do. And we're going to cover some of those very basics in the next Jupyter notebook.
That sounds fantastic.
Pablo, do you have any questions?
I am baffled by how much I have learned, even though I am supposed to know how to code. And you see, that is the difference between somebody that actually took took lectures and read and really put thought on understanding what is going on under the hood, and somebody that just had to survive coding as fast as possible.
I did my fair share of just survival coding.
So-
It looks kind of ugly.
It looks
but-
very good. So I am very glad that we're doing this for the next generations that are going to be able to learn these things in a good way. So join us for the next iteration. I thank you a lot, Daniel. This was extremely useful, and I hope to see you all very soon. Bye soon, friends.
Bye.